Okay, we're going to start today with some notes, and the first page 73 and 74 are graphing systems of equations. We're starting a new unit today. And 74 will be practice. So as you're watching these notes, remember that you can always pause to get caught up as we go through the notes. But again, page 73 is going to be graphing systems of equations. Page 74 is going to be practice. 73 looks like this. And again, as we're going through notes, please feel free to pause so that you can get caught up as we go through these important facts. So our new unit is all about systems of equations. And systems of equations are two, maybe you could have or more, equations, and they're going to be linear equations. So linear equations come in the form of y equals mx plus b or some variation of that. So they're going to have an x and a y variable. Two or more equations, so linear equations, in the same problem. And so we are going to today solve these by graphing. So we're going to be graphing two, not or more today, but two equations on the same graph. And so a solution to a system of equations is going to be the ordered pair, right? Because it's going to be on a graph. So today we're on a graph, so it's going to be the ordered pair. So x comma y that make both, since there are two, or all, equations true. So it's going to be an ordered pair. It's going to be an x comma y, and you can take that x value and that y value and substitute them into the equation, and it will work for both lines, right? So it's going to be true for both of them. And so today, since we're graphing, right, we're going to be putting these ordered pairs, or these lines, y equals mx plus b, we're going to be putting these lines onto a graph. And then we're going to be looking to see where do those lines intersect. So today, because it's a graphing problem, they're going to be the lines wherever they intersect, wherever they cross, that's the answer. That's the true, that's the x comma y ordered pair that makes both of them true. There could be special cases, right? Special solutions. There could be a no solution, meaning that those two lines do not intersect anywhere. They're never going to intersect. So they're parallel lines. Parallel lines have no solution because they will never intersect by definition. And we can identify really quickly that they're parallel lines because parallel lines have the same slope, but a different b or y-intercept. So they're going to have the same slope, the m is going to be the same, but they're going to have a different y-intercept. They're going to have a different b. Infinite solutions are going to be lines that have exactly the same, so multiple, right? Multiple ordered pairs in common. So parallel lines have no solution because they'll never intersect. Infinite solutions are the same line, meaning the m and the b are the same. It's the exact same line. When you graph it, you're going to have one line on top of the other. And so you're going to put one line down, and then when you plot the next one, it's going to go right on top of it. And that's going to have infinite solutions because they're literally on top of each other. So they are going to intersect everywhere. Not every ordered pair. It's not all of the ordered pairs. It's going to be any ordered pair that's on both of those lines. Parallel lines are never going to intersect, and so there's no solution. But if they're exactly the same line, if you get to there, you're solving, you're getting it to be y equals mx plus b, let's say it's in standard form, and you're solving for y out of that standard form, out of ax plus by equals c, you're going to solve for y. So remember, standard form and you're solving to get y alone. If you're manipulating, if you're solving for y in this equation and it matches the other one when it's in y equals mx plus b, those are infinite solutions. They're going to be exactly the same. So let's just refresh, right? We've already graphed, so this is just a review, but if we take this first equation and we identify the m and we identify the b, the m is 5 over 2 and the b is negative 3. So when I plot that, I'm going to go on the y-intercept down to 3 and put a dot, negative 3, right? And then from this dot, I'm going to go up 5, rise, over run, 1, 2, 3, 4, 5, over 1, 2, because it's positive, so I'm always going up and to the right. And I'm going to connect them. Then my second equation, if I talk about that, my m equals and my b equals. M is the coefficient of x. B is the plus or minus, the constant at the end. My m in this equation is negative 1. Make it a fraction over 1. And my constant is 4. So from here, I'm going to go up 4 because it's positive 4. And my slope is negative 1 over 1. Remember, that's rise over run. So I can do two things here. I can go down, because that's negative 1, a rise of negative 1, and a positive 1. And when you're graphing, the really great thing about this, I can go up positive 1 and backward negative 1. When you're graphing, the really great thing is that two ordered pairs should overlap. So the solution to this system of equations is this ordered pair right here. That's my answer. My answer, my ordered pair, now remember, it's x comma y. So I'm going to go over first and up. So 2 comma 2. And if I substituted an x value of 2 into this equation, I would get a solution, a y value of 2. And if I substitute an x value of 2 into this equation, I would get a y value of 2. So 5 over 2 times 2 is 5, minus 3 is 2. And here, negative 2 plus 4 is 2. So you substitute 2 in and you get 2 out. So let's practice some more graphing, right? So this top equation, my m is negative 1 over 2. Remember, that negative can go to the numerator or to the denominator. It does not matter. You just cannot give that negative to both because it creates a positive. And my b value is 1. So I'm going to go up to 1. And I'm going to go down 1, positive 2, down 1, positive 2. I can also go up 1, negative 2, up 1, negative 2. The more dots you have, the more successful you're going to be, because remember, you want your dots to overlap with each other. And so if you put all of those points from that slope on this line, it's going to work out a lot nicer for you. In this equation, my m value is 1/2. It's positive. Remember, the equivalent to 1 over 2 is also negative 1 over negative 2, because two negatives will cancel out to create that positive. And my b value is 3. I'm going to go up to 3. And I'm going to go up 1, positive 1, forward 2, positive 2. Repeat it. And then I'm going to do the same thing. I'm going to go negative 1, negative 2, because two negatives create a positive. My line wasn't perfect, but here's my point of intersection. My point of intersection, the ordered pair that they both share, is the solution, which is negative 2, comma 2. Again, remember it's x, comma y. So you have to be able to transition back and forth from slope, which is rise, over run, which is up and then over. You have to transition from slope to ordered pairs. Ordered pairs are x, comma y, which is over and then up or down. So let's keep practicing some more plotting of points. We're going to get into problems that are not written in y equals form. So we're going to have to get them into y equals form. So in this first equation, x plus y equals -2, I'm going to solve for y, meaning I'm going to subtract x from both sides. And my formula is now y equals -x minus 2. M is -1 over 1, and b is -2. So I'm going to go to -2. And my slope is down and positive, down, positive, down, positive. Up, negative, up, negative, up, negative, up, negative, up, negative. So here's my first line. I'm going to do the same thing over here. I'm going to solve this second equation for y. So I'm going to do 5x minus y equals -4. Subtract 5x minus 5x. -y equals -5x minus 4. I have a negative still here, right? That minus sign belongs with that negative. It's really a -1. So I'm going to divide by -1 to get y alone. And that's going to leave me with 5 over 1, because two negatives create a positive, x. You don't have to have that 1 underneath it. You can leave it there because we're going to be using slope. And so that might make it a little bit easier. And then over here, a negative and a negative, again, make a positive. So my m is 5 over 1, and my b is +4. We're going to go up to +4, but I have a problem. I can't go up 5, +5, and over 1, +1, because I'm off the graph. So I can change that to its negative value and go 1, 2, 3, 4, 5, backward 1. And again, because they're not the same equation, I know that they're going to have a solution somewhere. My solution is that ordered pair that intersects. Again, remember to transition from slope, which is rise over run, to ordered pairs, which is x over, comma y. So -1, or -1 again. I'm going to use 75 as my area to do these problems so that I don't, keep squishing everything together. So if I have number 4, my first equation is x minus y equals -2. I'm going to subtract x from both sides because, again, the goal is to get y alone. I'm left with -y equals -x minus 2. If you want to put a 1 in there, you perfectly can. Doesn't change the problem. Divide by -1, divide by -1. So y equals negative divided by a negative creates a positive x. Again, you could just leave it as 1x or just x. And here, negative and a negative create a positive. So I can plot that. I'm going to go to +2 because that's my y-intercept. And I'm going to do my slope, which is up and over, positive, 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 positive. I'm going to fill it in, so I'm going to do the opposite, which is negative, 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 negative. And there's my first line. Next one is x minus y equals 1. Subtract x, subtract x. -y equals -x plus 1. I can throw in some coefficients. Divide by -1. So y equals Negative divided by a negative creates a positive, and a positive divided by a negative, oops, that should be a 1. A positive divided by negative should be a -1. Now look, I have the same slopes, but different y-intercepts. Same slopes, but different y-intercepts. This will be a no solution because these two lines will be parallel. Let's prove it. Start at -1, because that's my y-intercept. And from -1, I am going to go positive, positive. And negative, negative. And I've created parallel lines, so this is a no solution. Because they are parallel lines, they will never intersect. Over here, these are intersecting lines because they have different slopes and y-intercepts, right? They're different lines. Number 5. 2x minus y equals -3. Again, I am solving for y. I'm isolating the variable y. -2x minus 3. Throw in a negative coefficient of 1. Divide by -1. So y equals 2x plus 3. Now I can make that over 1. So I can graph it, right? Because I have to have a fractional value to graph my slope. And I'll go over here to 3. And my slope is 2 over 1, so positive over positive, so up and to the right. I'm going to continue that pattern and go down and to the left. There's my first line. I will do the second equation. 4x plus y equals -3. I want to isolate y. That's always the goal. This is in standard form, and I'm making it into slope-intercept form. And y is alone. I don't have a negative. It's a positive coefficient, so I'm done. My intercept is -3, and my slope is -4 over 1. I go to -3. Again, always start on the y-axis. That's your y-intercept. I could go down 4 and +1, but that's off my graph. So instead of going negative then positive, I'm going to go positive then negative. So I'm going to go 1, 2, 3, 4, backward 1, 1, 2, 3, 4, backward 1. And again, we're looking for that ordered pair that they have in common, where they intersect. And that ordered pair is -1, comma, +1. Number 6. My first equation is x minus 3y equals -12. So I'm going to subtract x from both sides. -3y equals -x minus 12. I'll throw in a 1 there. Divide by -3, divide by -3. Y equals, two negatives create a positive, 1/3, x. Two negatives create a positive 4. So I go to 4, put my dot. My slope is +1 over +3, so up 1 over 3. I continue that pattern by doing the opposite, -1, backward 3. Then I have x plus 3y equals 6 as my second equation. Minus x, 3y equals, remember when you're writing this, you want your variable first and then your constant. Throw in a 1 there. divide by 3, divide by 3, y equals negative 1/3 x plus 2. Over here, that means I go to 2, and I go down 1, backward 3, no, down 1, forward 3, and then I'm going to do the opposite, which is up 1, backward 3. Again, we're looking for that point of intersection, which in this circumstance is negative 3, comma, positive 3. Number 7 will be x minus y equals negative 3 minus x, negative y equals negative x minus 3. There's a 1 there. Y equals 1 over 1x, positive 3. Positive 1, positive 1, positive 1, positive 1. My next order pair is just written backwards. 3 equals negative y minus 5x. If you want to rewrite it, you can. You can take that and put it over here. Doesn't matter. Add 5x. So I'm left with negative y equals 5x plus 3. Throw a coefficient of 1. Y equals 5 over negative 1, or you could take that 1, that negative, and put it to the 5. Doesn't matter. And 3 divided by negative 1 is minus 3. So I'm going to start here at negative 3. My slope was 5, 1, 2, 3, 4, 5, over negative 1 right there. I could do negative 5, positive 1, but I'm going to be off my graph. My solution is that ordered pair where they intersect, which is negative 1, comma 2. And last but not least, x plus 6 plus 2y equals 0. So I need to take this and put it over here so that it's in standard form. So I'll have x plus 2y equals negative 6. Subtract x, 2y equals negative x minus 6. Throw a 1 in there. Divide by 2. Y equals negative 1/2 x minus 3. So negative 3 is my y-intercept. And I'm going to go down and positive 2, or up and negative 2, up 1, negative 2, both are the same. Then my second ordered pair is 2y plus x plus 8 equals 0. So again, I'm going to take that plus 8 and move it over. So I have 2y plus x equals negative 8 minus x minus x. 2y equals negative x minus 8. Throw a 1 in for the coefficient. Divide by 2. Y equals negative 1 over 2x minus 4. Negative 8 divided by 2 is negative 4. So I'm going to go to negative 4. And I'm going to go down 1, backward 2. And I'm going to go up 1, backward 2, up 1, backward 2. And these have no solution Because again, if you look, my slopes are the same, but my intercepts are different. So they will never intersect because they are parallel lines.